Hi guys, and welcome back to my channel. This is episode number 6 of the Coastal Landscapes and Change series over here on my channel. Just wanted to make sure it was the right one. Today we're going to be looking at weathering and mass movement at the coast. I hope this is useful. This is episode number 6, as I say, so I'll link the rest of the playlist up here if you haven't seen it already. Go ahead, watch it, share it with whoever you think might find it useful. I'm mainly doing this because it's exactly what I wanted during my A-levels, and so I thought I'd do it for you guys. I study geography, and so I thought I'd be a pretty good person to do this for you. So please do subscribe down below if you do like this. I upload these every single week, Monday at 4:30 p.m, and I'm hopefully going to be going through the entirety of the specification. Why not subscribe? Join the fam. I also upload other things as well, not just geography content, but if that tickles your fancy, subscribe down below. Let's just get straight on into this. I'll stop rambling and let's get going. Reshaping the coast. A series of landslips has affected the Lyme Regis in Dorset since 2014, in a sequence of movements that significantly reshape the coastline. Less dramatic mass movements such as rockfalls also happen frequently all along this coast. These are important mechanisms for producing sediment for the sea to transport and redistribute. Subaerial processes. Parts of the North Yorkshire coast suffer from rapid erosion. However, subaerial weathering processes, such as weathering and mass movement, also helped make it worse. Weathering is the gradual breakdown of rock in situ, at or close to the ground surface. It can be divided into 3 different types: mechanical, weathering, and biological. By breaking rock down, weathering creates sediment which the sea can then use to help erode the coast. Weathering also helps to increase the rate of erosion on some coasts. Mass movement is the movement of weathered material downslope as a result of gravity. Mechanical weathering. Freeze-thaw weathering, also known as frost shattering, occurs when water enters a joint or crack when it rains. It then freezes in the cold weather. When water freezes, it expands its volume by about 10%. This expansion exerts pressure on the rock, which forces the crack to widen. With repeated freezing and thawing, fragments of rock break away to collect at the cliff base as scree. These angular fragments of rock are then picked up by the sea and used as tools in marine erosion. Despite the fact that the coast tends to be milder than places inland, freeze-thaw weathering is still important in coastal locations. For example, in 2001, following a very wet autumn and a cold February, freeze-thaw weathering triggered several major rockfalls along the south coast of England. Chalk, a permeable and porous rock, was the main rock affected. Salt weathering. When salt water evaporates, it leaves salt crystals behind. These can grow over time and exert stresses on the rock, just as ice does, causing it to break up. Salt can also corrode rock, particularly if it contains traces of iron. Wetting and drying. Frequent cycles of wetting and drying are common on the coast. Rocks rich in clay, such as shale, expand when they get wet and contract when they dry. This can cause them to crack and break up. Biological weathering. This occurs in several ways. Thin plant roots start to grow into small cracks on a cliff face. These cracks then widen as the roots grow thicker, which breaks up the rock. Water running through decaying vegetation becomes acidic, which leads to increased chemical weathering. Birds such as puffins and animals such as rabbits dig burrows into cliffs. Marine organisms are also capable of burrowing into rocks, such as piddocks, which are similar to clams, or of secreting acids, such as limpets. Mass movement processes. Mass movement can occur at a range of speeds from incredibly slow, less than 1 centimetre a year, such as soil creep, to horrifically fast rockfalls and slope failures that can cause the landscape to change in a matter of minutes. Mass movement at the coast is actually quite common, particularly because of the constant undercutting of the cliffs, making them unstable and prone to collapse. More often, the sheer weight of rainwater combined with weak geology is the major cause of collapse. Different types of mass movement. Mass movement can be classified in different ways. The resultant movement is dependent on a range of factors, including the angle of the slope or cliff, the rock type and its structure, the vegetation cover and how wet the ground is. Mass movement, flows, soil creep. Soil creep is the slowest form of mass movement and is an almost continuous process. It is a very slow downhill movement of individual soil particles. Solifluction, this movement averages between 5 centimetres and 1 metre a year. It occurs mainly in tundra areas where the ground is frozen. When the top layer of soil thaws in the summer but the layer below remains frozen as permafrost, the surface layer becomes saturated and flows over the frozen subsoil and rock. Earth flows and mud flows. An increase in the amount of water, such as the result of heavy rain, can reduce friction, causing earth and mud to flow over underlying bedrock. The difference between a slide and a flow is that in a slide, the material remains intact. In a flow, the material becomes jumbled up. Mass movement, slides. Rockfalls. Rockfalls are most likely to occur when strong, jointed and steep rock faces are exposed to mechanical weathering, such as freeze-thaw weathering. Rockfalls occur on slopes over 40 degrees. The material, once broken away from the surface, either bounces or falls vertically to form scree, known as talus, at the foot of a slope or cliff. Block falls are similar to rockfalls. A large block of rock falls away from the cliff as a singular piece, due to the jointing of the rock. Rock debris and slides. Rocks that are jointed or have bedding planes run roughly parallel to the slope or cliff surface and are susceptible to landslides. An increase in the amount of water can reduce friction, causing sliding. In a rock or landslide, slabs of rock or blocks can slide over underlying rocks along a slide or slip plane. Slumps. Slumps often occur in saturated conditions. The difference between sliding and slumping is that there is a rotational movement in slumping. Slumps occur on moderately steep slopes. They are common where softer materials such as clays or sands overlie more resistant or impermeable rocks such as limestone or granite. Slumping causes rotational scars. Repeated slumping creates a terraced cliff profile. And that is the end of episode 6. I hope you learned something. I hope you're taking something away from this. If you are, please do subscribe down below. It really helps me out. And you will be subscribed to see the next one. I'm uploading them every week, Monday, 4:30 p.m. I hope you enjoy. I hope, you found it useful. As I say, subscribe down below, share it with a friend, share it with your teacher, literally whoever you think might find it useful. Subscribe down below and see you next Monday, 4:30 p.m. Same time, same place next week. Bye guys.